Hello, everyone, and welcome to Lecture 6. Today, we will discuss the foundational ideas of ecological economics. In Lecture 5, we discussed about how traditional economic thinking often treats the economy as a self-contained system focused on growth, efficiency, and markets. However, we discussed that ecological economics, challenges this perspective by emphasizing that economy exists within ecological limits and therefore must be understood as a part of a larger ecosystem. So, at the heart of ecological economics is a simple but very powerful idea that the economy is not separate from nature, it is embedded within it. This means all economic activities depends on natural resources. The environment also acts as a sink for waste and pollution. Both these functions, source and sink, have limits. And when we ignore these limits, it can lead to major global challenges, such as what we discussed in the last class, climate change. It can also lead to biodiversity loss, resource depletion. So these are not just environmental issues, they are economic problems arising from exceeding ecological boundaries. Okay, let's just do a quick recap. So, this is where the lecture 5 actually, ended. If you see the diagram, this basically tells you that economy is a subset of a larger ecosystem, and so we cannot grow indefinitely. However, what is important to remember or just to recollect, what is important here is that the hierarchy, the ordering, and this is what Herman Daly insisted that we need to follow a particular sequence. And what is that sequence? He started by discussing scale, that is limit, and he asked this question, how big can the economy be relative to the ecosystem? So that's the first question. Daly puts the scale as the most important question. And so this is because the economy, as he already explained, is embedded in a finite biosphere, so we cannot have an indefinite growth. And there are biophysical limits in terms of source as well as sink. If scale exceeds this limit, then there can be an ecological collapse. So what it means is that no amount of efficiency or fairness can actually fix a system that is too large for the planet. This is the root cause also of several problems that we are seeing today. And so for him, if we ignore scale, we are actually asking a very different question. We are actually asking, how can we efficiently destroy the planet? If our focus is only on efficiency and not on scale, then basically we do not even consider that there is any limit and we might go on growing. Then it is about asking how far can we go ahead or go on and destroy the planet, right? So that was the first emphasis that he had put, that is on the scale, on limit. Next point here was that the next emphasis was distribution, equity. That means who gets what. And the question he asks is, how are resources and benefits shared? So once the scale is within limits, Daly says we must decide who uses how much of the limited resources. How do we ensure fairness across rich versus poor, present versus future generation? And why does it matter? It matters because resources are finite, so distribution is unavoidable, but it has to be done equally because inequality can increase environmental pressure because there can be overconsumption by the rich and also create social instability. So a sustainable system that is deeply unequal will not remain stable. So after we decide or after we get to know how big we can grow, we need to then focus on the distribution. Then comes allocation, efficiency, how resources are used. Or the question that he asks is, how efficiently are resources allocated? Now, this is where mainstream economics focuses, but Daly puts it at the end, last. Because why it matters? Because efficiency improves how we use resources, but efficiency cannot decide how much is used, meaning we do not know the scale. Efficiency cannot determine the scale. Further, it does not decide who gets what, the distribution. So markets are definitely good at efficiency, but they are blind to limits and fairness. Okay, so this particular order is for him is very, very crucial to stay within ecological limit, to share once we determine what this scale is, to share it fairly and then to optimize it, which is the allocation. Now, to make it even simple, just think of a cake, right? The scale will ask you how big is the cake, because cake itself is fixed. So if you start allocating it without even knowing how big is the cake, if you already decide without even seeing the size of the cake that you are going to get this much, you are going to get that much, then there can be a lot of chaos, because your cake probably is not large enough to provide you so much, right? So the first is, how big is the cake? Second is, okay, if the cake is this big, who gets how much? And then the third point would come, how do we cut it efficiently so that whoever needs to get what, given the fixed size of the cake, gets exactly that? So do you understand this, what I'm trying to say? So if you start by allocating, so now what the mainstream economists are doing, your main focus is allocation, efficiency. You are not aware of the scale. You are not even aware that how do you want to distribute it. You only start cutting the cake without knowing the size of the cake, right? So this is the biggest contribution, I would say, of ecological economics and also Herman Daly on clearly identifying the order or the hierarchy of understanding the economy environment relationship. Okay, let us now try to understand this diagram by thinking of the economy not in isolation. Now that you understand that economy is actually a large part of a larger ecosystem, so we know that economy is not working in isolation. As you see here in the center, at the center of the diagram, you see the economy. And this represents all human activities, production, consumption, trade, what we usually study in, traditional economics. But importantly, this economy is not flowing independently, because as you see, it is embedded within human social activity and beyond that within the ecosystems or biosphere. Now, if you look at the outer green boundary, that is the ecosystem. And this is the nature. This is where the nature comes, the forests, river, atmosphere, ocean. So the key idea here is that the economy is a subsystem of the ecosystem. And this is the fundamental in ecological economics. So this is the vision, fundamental vision of ecological economics. Now, what is important to, bring in here is, so far, I think by now you are very clear when we say that economy cannot grow forever, that economy is a subsystem of a larger system. Let me bring in another new element to this, and that is about open versus closed system. Let's understand the main concept of this particular slide, and this is about the economy as an open system. Now, why do we say that economy is an open system, or why is this shown in this diagram that economy is an open system? Because economy takes in energy and matter from the environment, such as fossil fuel, minerals, water, biomass. These are all that the environment provides to the economy. And then what does it do? It produces output, which includes goods and services, but also waste, pollution, and heats are generated, right? So the economy is constantly importing resources, transferring them, and exporting waste. This is why we call it an open system, because it can take things also, and it can also take out things. Clear? So that's why it's a system which is open. But now you look at the biosphere. We say that the biosphere as a closed system, particularly for matter. So you look at the larger system, the Earth or biosphere, it behaves differently. The biosphere receives energy from the sun as solar energy coming in. It releases the energy as heat back into the space. So fine, it's taking energy, it is sending it back. So here it is an open system. But what about matter? In terms of matter, it is almost closed, right? It's not that matters are dropping inside and then we are sending the matter out from the biosphere. This means that we do not get new matter from outside Earth. Whatever resources we use are finite. So if you have matter, say for example, fossil fuel, it is finite. It's been given to you. Now you cannot actually get more matter in from outside the Earth. So therefore, whatever resource we use are finite and recycled within the system. So the Earth is open for energy, but closed for matter. And this distinction is extremely important because in traditional economies, we often behave as if resources are unlimited. right? As if we can keep getting matters. They are infinite matter. So resources are unlimited. And then waste disappears somewhere, as if we do not have to look at the waste at all. Because we thought that the waste disappears on its own, that is why today we have this whole problem of CO2, because that's a waste which was created during our economic processes. It cannot go out anymore. It's just getting accumulated around the earth. So that's why we are finding it so hot. It's heating up the earth system. So what is important in this diagram is that the economy depends entirely on the finite ecological system. Resources are limited, closed system for matter. Waste accumulates because system has limited absorptive capacity. And another very important insight here is that energy flows in one direction: sun, economy, heat loss. Matter circulate or should circulate ideally, that it should be reused, recycled, and regeneration. If you do not recycle or reuse it, that means whatever matter you have used, it's gone. You will not get it anymore. It is gone in a very different way as well, not in the way you got it. So in reality, we extract resources faster than nature can regenerate, unfortunately. So for example, take the example of groundwater. Groundwater is a resource which is given to us. We know how much groundwater we have. If there is a natural capacity to regenerate groundwater, whenever it's raining, your water seeps through and your aquifer gets regenerated. But if you do not allow that time or amount of time that is needed for aquifer to get regenerated, then you will deplete your groundwater, which is again something which is we are seeing in our own country, right? So we extract resources, we extract groundwater much faster than it can replenish. So we produce also similarly waste much faster than the nature can absorb. So at the end, this leads to finally resource depletion, pollution, and issues such as climate change. So think of Earth like a closed box for materials. We cannot bring in new resources from outside, but our economy behaves like an open system, constantly extracting and dumping. That mismatch is the root of the environmental problem. Okay. All right. Now, this is important to remember, because this also is very clearly and closely related to the whole question of ecological limits. Now, let's begin with something very familiar with microeconomics. In microeconomics, if you remember, we discussed that we always ask a simple question: at what point should a firm stop producing? And the answer is very clear, that the firm should stop producing when marginal cost is equal to marginal benefit. This is what we call in microeconomics the when to stop rule. It ensures that production is efficient, neither too much nor too little. Now, the key question, and which, if you remember, we also discussed when we were talking about environmental economics, that even environmental economics could not provide us an answer, that why don't we apply the same logic to the entire economy? And then we ask, at what point should the economy stop growing? So the problem with conventional thinking is that in the mainstream macroeconomics, there is no clear, when to stop rule for growth. Why? Because the economy is often treated as an isolated system, and growth is seen always beneficial. More production is always more welfare, and there are assumptions that there will be no real limits. So therefore, and also if you remember, we discussed about this, that there are no opportunity costs to grow, as if we are not giving up anything when we are growing. We are growing in void. So growth is always encouraged. But why this assumption fails? And this is where we call upon a concept called empty world. And what is actually an empty world? Empty world is a world where there are few people, abundant natural resources, minimal environmental pressure. And in that context, expanding the economy has very low ecological cost. So growth seems unquestionably good. Right? So this is where we also bring in this particular diagram, where you actually see very nicely that there is on the top is something like empty world, and below is something like a full world. Let me explain this diagram to you. To begin with, consider the empty world shown on the top diagram. In this situation, the economy is relatively small when compared to the vastness of the economy. Nature is abundant and natural capital is also plentiful, while human-made capital occupies only a small portion of the system. And what is this human-made capital? Something that you and I make. For example, roads, bridges, all of these are very little, very small portion of the system. Largely, it is the natural capital, that is rivers, forests, all of these are much plentiful compared to the human-made capital. In such a context, resources are easily available. Waste generated by economic activity can also be readily absorbed by natural system. And ecosystem services, if you look at the arrow, if the ecosystem services such as clean air, water, bioservices are not scarce. And because of this abundance, economic growth in an empty world largely adds to human welfare. So in an empty world, you actually look for economic growth because you feel that it's going to, if you have better connectivity, better, roads, all of these amenities, when what we are today, we have access to, if you have more and more, it is considered that it is going to add to human welfare. So expanding production and consumption does not significantly harm the environment. Therefore, the cost of growth remain very low. When you begin growing, this is the situation you confront with. And this is essentially the world in which traditional economic theories were developed, where growth could be seen almost entirely beneficial. Because when we are talking about 18th century, 19th century, at that time economy was an empty world. When we have lesser people living, we had a lot of resources. So most of these economic theories that we are talking about today were developed during those times. But however, the problem that is that why these theories today fail to give a lot of answers is because the situation have changed dramatically. When we move to what ecological economics describe it as a full world, below what you see represented by the bottom diagram is the full world. Here, the economy has expanded to the point where it occupies a large share of the ecosystem. Natural capital is no longer abundant. It is limited and increasingly stressed. Resources begin to become scarce. Waste accumulates faster than nature can absorb, and ecosystem services start to decline. Right? In this context, further economic growth creates a trade-off. While we continue to gain more goods and services, we simultaneously lose valuable ecosystem services. For example, more industrial production may increase income, no doubt, but it can degrade air quality, reduce biodiversity, destabilize the climate. So growth, therefore, is no longer purely beneficial. It comes with real and increasing costs. This brings us to the central idea of the slide that growth is not free. Unlike expanding into empty space when we initially started growing, economic growth takes place within a finite Earth system. Every additional unit of growth now comes at a cost, whether in the form of deforestation, loss of clean air, depletion of water resources, or climate instability. These are all the costs that we are paying for the growth. The slide also emphasizes that human welfare depends on two sources, economic services and ecosystem services, right? In the empty world, both of these can increase together. So one thing to remember is that even ecological economics considers that welfare does not depend again only on ecosystem services. We also do need economic services, but in the empty world, both of them actually is increasing together. You are not, depleting one to get another. But in a full world, increasing economic services often leads to decline in ecosystem services. And this means that overall well-being depends on balancing the two rather than focusing only on one, that is economic output or GDP. But you don't actually do anything to safeguard your natural ecosystem. So the broader takeaway, therefore, is that Earth is not an empty void. It is a life support system. Economic activity must be evaluated not only in terms of benefits it generates, but also environmental costs it imposes. This leads to the idea that there is an optimal scale of the economy beyond which further growth can become harmful. I mean, you can clearly see that if you continuously grow, and we, as of now, we don't even know whether we are in a, I mean, of course, we are in a full world situation, but how full are we? Unless we know that scale, we would, we are actually going to bring more harm rather than growth giving more welfare or further growth can actually lead to more harmful impact. In simple terms, we can actually say that in the past, the world was relatively empty and growth came with very little cost, no doubt about it. Today, however, the world is full and further growth often damages the very ecological systems that sustain life. Growth can certainly be beneficial, but beyond a certain point, it becomes uneconomic, reducing rather than enhancing human welfare. And we are going to discuss about this uneconomic growth a bit more detail in the subsequent slide, because it actually brings us to very important ideas, which is the diminishing marginal return is one idea, and the other one is the uneconomic growth. So first question that we need to ask is, what is diminishing marginal returns? So diminishing marginal returns actually means that when we keep increasing one input, okay, remember, when we keep increasing one input while others are fixed, the additional output from each extra unit eventually decreases. Let me simplify this a bit. Imagine a small farm. And if you have one fixed piece of land, your land is fixed in that piece of land, and you keep adding more and more workers, right? Initially, you have one worker, which is going to give you small output. Then you will have two workers, which will increase your output more because you have still space to accommodate those workers in the land. Then you add another one, that is three workers, your output even grows further. But after a point, after you add your 1, 2, 3 workers, when you move to the fifth worker, it adds, but it adds less extra output than it added when you had the third worker. So while you are increasing your output, but that increase is lesser than what it was earlier. And so this goes on. When you move to the sixth worker, it adds even less. This is called diminishing return. So your return starts coming down with the increase in additional unit when you have a fixed piece of land. So land is limited, worker starts getting into each other's way, and so efficiency starts falling. So each additional worker contributes less than the previous one. So the key idea here is that the total output still increases, but the increase becomes smaller and smaller. And so the extra output is called marginal product. If you remember, we discussed and I explained to you what is marginal when we spoke about marginal cost is equal to marginal benefit. So the extra output is the marginal product. And when it starts falling, we call it diminishing marginal return. So you are getting some return, and this return is falling every time you're adding a new labor. So we call it as a diminishing marginal return. Now, to give you a very simple example, think of eating food. For example, the first slice of pizza, very satisfactory because you are hungry and you had your first slice of pizza. Second slice is still good. You can still have it. Fourth slice, you had the first, the second, the third. When you go to the fourth slice, your friends have to actually tell you, please eat it, we have to finish it. And the fifth one, you would say, no, I just cannot eat. So what does it mean? From first to the fifth to the sixth, your return, your satisfaction started to come down. The extra satisfaction starts declining. This is what is actually similar, very similar to diminishing marginal utility. This can apply for various other examples. We also give the example of a glass of water. When you come from, say, playing a game and you come home and you get a glass of water, you drink it, with a lot of satisfaction. Then you try to sometimes also have the second one. The second one, probably you can't even finish. Somebody offers you third one, you would say no. So that's the diminishing marginal utility. Now, why it matters in ecological economics, the idea becomes very important when we actually think about economic growth. Early growth, high benefit, because we are talking about empty world. Later growth, smaller benefit, but still we have not reached to that full world. Eventually, cost may even exceed benefit. So that's why you see diminishing marginal utility of growth. Okay, and this is also known as uneconomic growth. So let's just move on and let's try to understand this very interesting figure that you see on the right side. So here, let me first bring out this again, another very similar concept which we had discussed is the marginal utility. Now, what is marginal utility? Marginal utility refers, Like the way I mentioned that marginal return is additional return if you are getting by adding one worker, marginal utility refers to additional satisfaction we derive by consuming one more unit of a good. So the first pizza gives you certain amount of utility, the second adding to the first, the third adding a little lesser to the first. So that is the utility, and these are known as marginal utility. An important principle here is that marginal utility declines as consumption increases. I already explained this to you, that when you start consuming something from one glass to second glass to third glass, utility is nothing. Remember, utility as satisfaction. So your marginal satisfaction, that satisfaction of consuming the last unit, keeps coming down. And as we consume more, each additional unit is giving us now less and less satisfaction. So just to repeat myself, for example, the first glass of water when we are thirsty is extremely valuable, but by the time we reach the fifth glass, the additional satisfaction is much lower. All right. So that's the marginal utility. Next, you have to remember what is marginal disutility, because it is shown by the lower curve. So you can see the marginal disutility curve. That's the lower curve. So marginal disutility refers to the costs associated with economic growth, which means that this includes factors such as pollution, resource depletion, loss of leisure, environmental degradation, congestion. All of these are marginal disutility. While marginal utility, starts decreasing with additional unit of consumption, but in case of marginal disutility, it's other way around. What happens here is that as the economy expands, the cost tends to increase. So while marginal utility is declining with more consumption, marginal disutility is rising with more growth. What does it mean? Meaning, as you are trying to grow more and more, your loss of leisure is now more, environmental degradation is more, congestion is more, pollution is more. So what do you see? This disutility is growing more, is increasing, whereas your utility is coming down. So this brings us to the most important point on the graph, which is point B, which represents the optimal scale of the economy. So at this point, marginal utility is exactly equal to marginal disutility. In other words, the benefits of growth are exactly equal to its cost. So like in case of firm, we said MC equal to MR. This is exactly the case for the macroeconomy. This is where actually your net welfare is maximized. And ideally, this is where the economic growth should stop. If you can identify this point B, then probably we would never reach a situation where we are today with very serious problems such as climate change. However, what is happening today, if growth continues beyond this point, we enter the region of uneconomic growth. So between the points B and E, the costs of growth begin to exceed the benefits. Although the economy continues to expand, the additional satisfaction we gain becomes smaller and smaller, while the damage we incur becomes larger and larger. So growth in this phase no longer improves well-being. At point E, marginal utility falls to zero. This means that further growth provides no additional satisfaction whatsoever. Yet the costs associated with growth are still very high, positive. So even though the economy continues to grow, we are no longer becoming better off, because we will have many, many problems, including, say, health problem. We can't even go out of our house. You may have seen there are many movies which shows that in the future we will be wearing, some kind of mask, because if the air outside is no longer good enough for us to even breathe. So we basically are a situation that is where we are approaching. But if growth continues even further, we reach point D, which represents a catastrophic limit. At this stage, marginal disutility becomes extremely large, approaching infinity. This reflects severe environmental damage or even ecological collapse. Interestingly, in this, so what I have written, it's more like a humorously that the end of the world as we know it, and we feel fine. Basically, what I'm trying to say is that we may not even fully recognize the severity of the damage we are causing. So basically, all of this connects to the central question in ecological economics. When do the cost of damaging ecosystem exceeds the benefit of additional production? The answer actually lies at point B, and that is the optimal scale that we have been discussing. So we can say that economic growth initially makes us better off, but after a point, each additional unit of growth brings smaller and smaller benefits and with greater cost. So marginal utility starts falling, but marginal disutility starts going up. Eventually, the harm outweighs the gain and the growth becomes uneconomic. So the key takeaway, therefore, is that while growth is beneficial in the beginning, it cannot continue indefinitely because benefits diminish, costs increase. And so there is a clear limit to beneficial growth. Beyond that limit, further growth can actually reduce human well-being. And you need to think about it and ask yourself, is it not true? I mean, there are so many new issues, new problems. Today, we are spending all our resources to move from something like fossil fuel to now greener technology. Why? Because, we know now that we will be reaching a catastrophic stage if we do not stop doing that. Okay. Now, this next slide basically highlights what we call as a paradigm shift, a fundamental change in how we understand the economy and its relationship with the environment. It is not simply a disagreement over policies or methods, rather, it reflects two very different ways of seeing the world. To begin with, we may ask, why do neoclassical economics often fail to recognize problems such as the idea of a full world, diminishing marginal returns to growth, or possibility of uneconomic growth? So the answer lies in the assumption underlying their framework. Because neoclassical economics largely operate within an implicit belief that we are still living in what can be described as an empty world where natural resources are abundant and environmental constraints are non-binding. And in such a setting, the marginal benefits of costs are still considered to be very high, while the marginal costs, particularly the environmental costs, are considered relatively low. So benefits are still considered to be higher than the cost. And so it is understood that we are still in a very empty world and we still have many resources available for us to actually grow. This perspective reinforced a strong faith in technological progress. There is an expectation that technological innovation will continuously overcome resource scarcity and environmental degradation. As a result, costs associated with growth are not perceived as likely to rise to levels that would outweigh its benefit. More fundamentally, there is actually a deeper conceptual issue, a paradigm problem. So in conventional economic thinking, the economy is often treated as an isolated system, as I had mentioned to you, because it is considered that economy itself is a whole. It is not a subsystem. Okay, and it's an isolated system, largely independent of ecological constraint, and this allows for the assumption that economy can indefinitely grow without encountering any hard limits. Now, ecological economics, as we have been discussing, challenges this view at its core, and that's why we say that there is a paradigm shift. It starts from a very different premise that the economy is a subsystem of a larger finite ecosystem. Now, from this perspective, growth obviously cannot, continue indefinitely because it is ultimately constrained by the limits of the Earth system. Consequently, ecological economics introduces the idea of an optimal scale of the economy, and actually it envisions a steady state economy where economic activity is maintained without sustainable limits rather than expanding without bound. So what makes this a true paradigm shift is that both perspectives are internally consistent within their own assumption. If one believes that resources are effectively unlimited and technology can solve all constraints, then continuous growth appears both logical and desirable. So if you belong to that school of thought, who feels that technology can actually, take care of all of the constraint, then, growth appears to be very much logical. And also it is very much achievable, desirable. However, if one recognizes or if one belongs to the school that finite nature of ecological systems or recognizes the finite nature of ecological system, then limits to growth becomes unavoidable. And the idea of perpetual expansion also becomes absolutely unrealistic. And for this reason, the difference between these two approaches is not really superficial. It is deep, fundamental, and difficult to reconcile. It reflects, two fundamentally different ways of understanding the relationship between the economy, nature, and human well-being. Now, because I'm talking about, that can human capital replace natural capital, this actually also brings to a very, very important concept in ecological economics, the idea of substitutability of capital and the distinction between the different types of capital. So to begin with, we need to understand that not all capital is the same. So broadly, we can think that there are two types of capital, human-made capital and natural capital. Let me tell you, this is the first time when ecological economics came in, we actually made these distinctions. Otherwise, irrespective of whether it is human-made or natural, all capital was considered to be one. And human-made capital includes what kind of capital? The capital that is created by people. This can be further divided also like in manufactured capital, such as factories, roads, buildings, and human capital, which includes education, skill, knowledge. These forms of capitals are central to economic production and are typically the focus of traditional economic analysis. So most of the investment that happens is to build this human capital, be it manufactured capital or the human capital. So most of the investments are actually happening on human-made capital for traditional economic analysis. Whereas in contrast, there is something called natural capital, which refers to stock of natural resources and ecosystems that provides valuable goods and services over time. So for example, forest can be harvested to produce timber, which is an ecosystem good. At the same time, if left intact, if you leave the forest the way it is, the forest also provides ecosystem services such as soil conservation, climate regulation, recreation benefit. So natural capital is not just a stock, it is also a life supporting system that continuously generates flow of value. Now, if you do not invest the way you invest on human capital, if you do not invest equally in the natural capital, then you are basically trying to substitute your entire natural capital, that means the role that the forest does, with timber. Now you can think whether that is at all possible. So the key question is, can human capital replace natural capital? And this is something that one needs to think. And this is where we encounter these two schools of thought. The first idea, which we call it as weak sustainability, it suggests that yes, human-made capital and natural capital are largely substituted. Right? So it basically says that if you cut all the forest, you can substitute this forest by something which is made by human. According to this view, as long as we continue to invest in human-made capital through technology, infrastructure, knowledge, we can compensate for loss of natural capital. For instance, if a forest is lost, we might replace its functions through technological solutions or engineered systems. All the function that forest plays, we can develop a technology and that can actually restore all that lost functions. The second perspective is that of strong sustainability, which argues that natural capital and human-made capital are not substitute but complements to each other. Why they are complementary? Because if you do not have enough natural capital, which is a very important source of your economic growth or economic development, then even your economic growth will suffer. In this view, certain functions of nature, such as climate regulation, biodiversity, or stability of ecosystem cannot actually at all be replaced by human-made system. You cannot build a machine that fully substitutes for the function that what an ecosystem functions, the way the ecosystem functions. Therefore, this school of thought emphasizes that natural capital must be preserved, not simply replaced. This distinction is crucial because it reflects two very different approaches to sustainability. Weak sustainability allows for continued economic growth with the assumption that technology will compensate environmental loss. Strong sustainability, on the other hand, emphasizes the need to maintain critical natural systems, recognizing that they are fundamental to long-term human well-being. So in a sense, this slide is asking us to rethink a very basic assumption of economics, whether all forms of capital are interchangeable or whether some, particularly natural capital, are irreplaceable foundations of economy itself. So this is something where I'm going to stop here. In the next module, this is where we actually end our module 1. In module 2, we will take this discussion further. So thank you.